Okay. So yeah. So it'll begin now. People will join later on. So yeah. So how this gonna work is we have created a presentation with the basic points, and then I'll walk through it. And we have some code examples to try out stuff, and then I'll share the final code file after this ends, and you guys can go through it, practice it. It's your way. And once people change their names, we'll take some attendance so that we could provide certificates. The game is providing certificates. So yeah. Okay. So I guess we should start with the actual course. I'll share my screen. Yeah. So yeah. So what is this all about? Data science projects from Acha, okay, one more thing, the meeting will end at 11:30, so we'll share a new link to rejoin, because again we are on non-pro account, so it will end in between. Okay, yeah. Coming back to the, I should stop the video. Yeah. So yeah, coming back to the topic, data science projects from inception to delivery. So exactly, what does it actually mean? So the first part is basically data science, that is using data to drive insights, to create models, to create projects that could predict stuff, predict stocks, predict customer retention. A lot of things can be done with it. And as we got the responses, a lot of people have actually joined some courses, like 20% of people have joined some courses. So we try to keep this training a bit different from the online courses. So what we are going to do is we are going to try to teach everything from the start to the end, not just machine learning, not just data cleaning, but then from the start, how do you actually start a project, how do you negotiate, till the time where you actually deploy the model for the use. So yeah, so inception is when you start the part where you like actually the when you like start the practice, and delivery is the deployment. So yeah, so starting with it. Okay, so there are a couple of terms that I might use during the speech. So what's a pipeline? Pipeline is basically a set of steps that you keep on executing, and the output of one goes to the input to the other, and all these parts form a complete model for your output. So there is a single output, and there may be multiple inputs, but in the end there has to be a single output in most cases. Who's a stakeholder? Stakeholder is basically anyone who has a legal say in the decision making. So there, it might be your boss, it might be your customer, it might be your the people who are going to work on the project. So these guys basically decide on the topics, like the scope of the project and who is going to do what. That's basically a stakeholder. GDPR is a set of regulations by European Union. Countries like France, Italy, they have this European Union who have formed this data protection regulations. So every company or organization who wants to work with people in the EU citizens, they have to follow these regulations. So they become a bit difficult to handle at sometimes. Yeah, but then yeah, you have to follow it if you are using their data or anyone linked with the European Union citizens. Data analysis is a process of discovering usable information from data. It's a single time activity in which you use some data, maybe run some visualizations, create some charts and all, and deliver your report. It's basically mostly a single time duty, and then you go ahead doing it again if it's necessary, but then it's not automated. So yeah, these are a couple of terms that we might use. And again, what we want to achieve in the entire course. So yeah, we'll start with basically the difference between artificial intelligence, machine learning, deep learning, data science. Then we'll go for defining the problem, like how do you actually define a problem for data science. We'll see why it's important. We'll see what are the requirements that you need to gather, how do you gather these requirements. Then you have to design the solution. Then you need to search for your data, like the data that you are going to use. Then comes your cleaning data, exploratory data analysis, basically trying to gather some early insights from the data. Then feature engineering is generating new features. We'll see all of these in a few hours, I guess. I mean, in the due course. And then you train the models. This is the only part that where you use machine learning in the entire pipeline. So all these activities, they become they send their outputs as it's a pipeline to this part where you actually train your models, and then you deploy it. Yeah. So I guess we'll start with the difference. So AI is when you simulate human intelligence into machines. So what this means is basically any time when you simulate any kind of intelligence that's related to motion, that's related to how we talk, what we do, that's all included in the AI part. Then comes your machine learning. That's when you use past experiences to train. That's when you use past experiences to train. And then deep learning is when you use neural networks for machine learning. That's another, that's a subset. How these people are related, it's in this way. It's a subset of machine learning. Deep learning is a subset of machine learning, which is a subset of AI. And then now to the topic of the course, data science. Data science uses machine learning. And as we saw, it has all of these extra activities included apart from machine learning. It's not just machine learning. So yeah, like that's the most famous part, machine learning and deep learning. But then yeah, it's only a small, very small part, 10-20% of the entire pipeline. I mean, yeah, if you specialize and you get a job in ML, then yeah, it's only ML for you. But then it's rare. You have to do other stuff like cleaning data, and EDA is necessary for you. Okay, so to the second part is, how do you define a ML problem? So I've written a small example. So traditional software engineering involves problem definition. This is similar to it. So first of all, what is it? So defining problem is when you need to know exactly what the stakeholders want. They might want something, a single of activity, that's data analysis. It's not actually training models. Or they might just want you to create some pipelines of data, like the data is getting inputted from your, that's ingestion, then you have to store it here, that's storage. They might not want you to actually do data science. That's why you actually need to know why, like why do you need to know that? Like, I mean, why do you need to ask these questions to them? And the second part is, why is it necessary? Yeah, as I told, is data science may not be necessary in a specific problem, so you need to define your problem very nicely. And then the point comes is how to do it. So it's very simple. You just ask the correct questions to the stakeholders, and once they start answering, you know exactly if you need data science or not, or what's exactly that's needed. So first, a couple of questions that you can ask is, how many times do you want this like these predictions to be done? Is it a single of case? Then it's data analysis. So I'll have to do some analytics on the data, create some visualizations, create a report, and I'm done with it. But if they want this has to be done every time a customer adds a item to his basket, so or when you're shopping on Amazon, and every time you add an item, you get other items related to it. So that's basically predicting how you shop. So that's not a single time case. So yeah, that could be the answer of how many times do you want it. Other question could be, what kind of data am I allowed to use? uh, do I want to deliver the reports? So this is a small example, a very detailed problem definition. So they want a product that predicts the customer retention once every day by accessing data from unclassified and stores the probability in a database. So what this actually means is, they want you to predict the customer retention. Customer retention is, if will the customer staying with the company and not going to some other competitor. That's customer retention. So you want to predict if a customer would stay with you. And they want it to be executed every day. So now you know it's a ML problem. It's not just an analytic problem. It's a ML problem. That's where you know. Then they want you to do only use only unclassified data. Unclassified data is basically data that's available to everyone. They don't want you to use any data that's classified or restricted in access. So they want to use only the unclassified data, and they want you to store the probability in a database. They don't want you to predict runtime on each request. They want you to just store it in a database, and then people will access it. And they want you to create schedule reports. Yeah, this is a simple example of problem definition. And we saw why is it necessary, how to do it, and wha- what is it basically. Okay, you guys can take notes if you want. Yeah. So the third part is basically requirements. So we would want to know exactly what do we have to do in the project, because usually these ML machine learning projects are pretty costly, because the people who are working on it, the salary prospects of people who do machine learning, that's very high. And then the infrastructure costs, I mean by infrastructure I mean your computers and your servers and your cloud included, everything is a bit costly. And then it's risky too, because you have to make sure that you are not infringing anyone's copyrights, you're not using any data that you are not supposed to use. For example, if you are working with European Union citizens data, you need to make sure that you follow GDPR. So you need an entire separate compliance team that takes care of that. So that's also like an entire team just for compliance of GDPR. That's also costly. So yeah, so you want to know exactly what do you as a data scientist have to do. So a couple of questions, again, this is again what questions you ask, because you are the person who are going to do it, so you should know what questions you have to ask. The person sitting in front of you may be a layman, he might not be even a techie, he might be just a MBA person, so an executive. So yeah, you have to ask the correct questions. It's your responsibility. So examples, what's the end product expected? That's basically, do they want the uh, thing to predict stuff? Do they want you to give you Boolean answers like this is possible or this is not possible? Or do they want you to predict regressions, that's basically predicting house prices and all? Or do they want you to segment a customer, they want you to segment the customer, segment it into genders, or segment it by their buying habits? That's basically the end product they want. And then again, you need to make sure that is this a one-time analytics solution or it's a ML product. That's again the same thing, you have to ask them how many times do you want to run this. Then the question comes, is the solution needed to be deployed? So many times companies, they wanted to create a proof of concept. A proof of concept is something that just depicts that just the final output of that entire work is to decide if this solution is possible. That's the entire idea of proof of concept. So you want to make sure to ask them that is this just a proof of concept or this is going to be finally deployed? How does it differ? So if it's just a proof of concept, you are slightly more opportunist, like you get more opportunities regarding the use of libraries and data that you can use. Like you have to convince the stakeholders and not the actual customers. So it makes slight difference in your how you work. But then in the end, you should be as close to a solution that has to be deployed. But then yeah, some minor differences are there. Then you want to ask them, should are you responsible to create the pipelines too? Now this pipeline is not the pipeline that I was talking about, the data science pipeline. This pipeline is basically how the data flows through the system. So most businesses, they have these online transaction processing systems, the databases. So they you have to get the data from databases, probably store it into a data warehouse or something larger. A data warehouse is a larger place where you store data. You don't care a lot about atomic properties. and then you create your pipelines to access the data and then give the output. So you want to ask them, am I as a person responsible for this pipeline, or they have hired other people, the data engineers, to do this properly? So if they have hired other people to do this, you just have to work on your analytics and predictions, your ML models. But if they have not if they have not hired other people, you are responsible for getting the data, working on it, like creating the pipeline, writing pieces of code, how the data should be taken, what transformations should be applied, what's the granularity is basically drilling down. For example, you might want to work at the aggregation layer of the year, or you might want to go to the date level, or you might want to go to the month level. So all of these is your responsibility. The fifth point is basically, is model explainability needed? So do they want you in the end to actually show them how the model works? So all models basically are not explainable to the same extent. It's very easy to explain a decision tree model. The decision tree model is basically the output is if else statements. So the what your ML model does is it takes a parameter, does something on it, like decides if for example, if it's a house price prediction, it will first check what's the price of the house. If it's greater than 10, it has to predict the prices. So it will check the locality. Is it Mumbai? So it will know that the price is going to be a bit higher. Then it will check what's the area of the house. If it's greater than 10,000 square feet, so you apply 100 rupees per square feet, something on those lines. So it's easier to explain that model. Then what else you want to ask is, are there any time constraints? So do you want the project to be completed in a specific time duration? And mostly there would be some time duration, and depending upon the time that you are provided, you have to decide what's the complexity that you want to do. So basically, training a neural network would be a bit difficult, because there are much more parameters to train and test as compared to training a decision tree or training a logistic regression model. Or maybe if they provide you more time, you can generate more features, go much deeper into the analytics part, and actually learn stuff like the actual business problem and all. Like, you can go really deep if they provide you more time. The output would be really nice, but then it all depends on how much time you had provided. The other type of time constraint is how fast they want the final output to be. So they might want you to predict 1 million requests per second. So you don't want to use a very difficult model for it. You want to use a simple model that predicts stuff quickly. They might, if they are allowing you, okay, it's very sparse, you can take your time, you can take the data, work on it an entire night. Like, this is all about the inference part, like the final part where you have deployed the model and then they are using it. This is this time constraint. So you want to make sure that it's usable. So that also you have to take care. And then again, are there any regulations to take care of? So they have to tell you if they are using any data from European Union citizens, or they are using any data from other parts. So yeah. Okay, yeah. So there are only two more slides left. Then we'll take a quick break, and then we'll come back for the coding. So yeah. So how do you design a project? So it's a very huge topic. I mean, you can work week, you can like come every day, a week. I mean, you can spend weeks on it, just studying how to design. And again, it's something that you get with experience. So yeah, some points before we start the examples. A data science project is not just a prediction model. It's not just some data that you feed to a model, then it starts providing you outputs. It includes all the parts. So you have to take care of everything: how you get the data, how you like use it, how you provide it, and then how you deploy it finally. So, and there are various parts again, and they all have to be systematically designed. So you need to actually sit in meetings and decide on every single part, as you do in a typical software engineering project. Some examples that you will decide are the data ingestion pipeline. So you want to know how do you actually get the data at the training time, as well as the time when you are predicting, when you are inferencing. Getting inferences is similar to getting prediction. I mean, I'm using the terms interchangeably. Yeah. And then so the data ingestion pipeline is basically the extract, transform, load parts, or the parts where you get the data into your Python or R runtime or Tableau runtime, whatever environment you're using. So that's also a part of the ingestion. And then you need to uh, transform it, in the sense there may be some discrepancies, or there might be data that you are not allowed to use. That all happens in the ingestion part. These are like softwares like Hadoop have MapReduce, software like Elasticsearch has Elkstack has Logstash to work with it. So those are configuration files, or they can be linked to your Python files or Java files, whatever. It's basically transforming your data. Then the flow of the data, this is when it flows through your system. So you have got the data, now you have to do your own transformations. You want to remove null values, you have to take care with the fields or the row columns in a typical database language. You have to take care what all from them are useful or not. You have to remove them, you have to convert it to normal numerical values from strings that we'll see in a few in the next session. And then you have to decide on the output delivery mechanism. That is when you decide how will you finally give the output. You might want to provide it as a dashboard. You are just providing a API. API is something that other web developers can access your uh, code by through HTTP. If you are using a web API, they can access it through a HTTP call, like a web to give an example, all these websites that you load are all HTTP GET requests. If you want to create if you want the output to be delivered in that way. And then comes interoperability. That's how the system would be deployed. So you want to make sure that the system that you are creating, you would be able to deploy in the final stack. What I mean by this is, when you create a data science project, it uses a lot of other libraries, frameworks. It's dependent on a lot of other things. Although Python is platform independent, but then the libraries might be using some internal systems that might not be independent. So you want to make sure that when you deploy the model, when you complete the project and you're going for deploying, you shouldn't have any issues. So that you should decide it before that. So yeah, this is also an important part. These were just examples. Again, there are a lot of other things that you need to decide upon. uh, these were just examples. In the next part, we'll see how do you get the data that you need. So when we are practicing data science, or in cases when the topic of your project is just something that's very common. The data can be, you can access the data that others have created. Then you can use these websites like Kaggle and UCIML, or Google has released a new search engine that's specific for Google for data sets. Or for example, some other websites like MIT, ERD, they release their own data sets, and if your problem can be solved by their data sets, good enough, we can just use their data sets. Then there are legacy systems, your online transaction processing systems that the company already uses. So they have their customer relationship management system, they have their I guess they have their ERP, enterprise resource planning systems. They have all these systems, all these databases set, and you might want to use some data from there. Go ahead, ask them. If they allow you, use it. Or you might want to outsource it. Outsource is basically when you get some other company to collect the data that you need. You tell them this is the kind of uh, questions that I want to ask the people. Please ask them on my behalf. And once you get the data, you can use them. So yeah, I'm done with the parts that were just theoretical. Next part would be all coding and all, like uh, practical stuff. So we have 2 more minutes here. If you have any questions, write it in the chat box. I'll go to them.